I'm Chris Mawata, and I want to introduce you to frameworks and best practices for AI governance. I have been a Learning Tree instructor since the year 2000, and I've written more than 40 courses for Learning Tree. I've also worked as a professor of mathematics at the University of Tennessee at Chattanooga and published papers in mathematics, machine learning, and visualization. So what are the key frameworks that we have for AI governance? Well, we have a framework from NIST, the AI Risk Management Framework, or RMF for short. NIST is the National Institute of Standards and Technology. It's a non-regulatory agency in the US Department of Commerce. We also have ISO/IEC 27050-2. ISO is the International Organization for Standardization. It's a global non-governmental organization. And IEC is the International Electrotechnical Commission. That's another global non-governmental organization. So let's take a look at the NIST approach to AI governance for starters. So NIST has a document, the Artificial Intelligence Risk Management Framework, or if you like, AI RMF, and it addresses the challenges of risk management in AI. What are the challenges that one needs to look at? Well, there is the actual management of the risk itself, the risk tolerance of the organization, risk prioritization. You will have multiple risks. Which are the ones that are more critical than the others? And then integrating the risk management into the operations of the whole organization. The framework is organized as the main part, AI RMF Core, which contains things that are relevant to all areas of AI. And then there are many AI RMF profiles, which concentrate on particular areas of AI. Let's take a look at NIST's AI RMF Core for starters. So they talk about the possible harm and impacts of your AI system, possible harm to people, think of individuals, groups, or society, harm to organizations, such as business operations, monetary loss, reputation loss, harm to an ecosystem, for example, the financial system, the supply chain, natural resources, the environment, even the whole planet. And then they also talk about challenges to managing the risk. And a big one is the measurement of the actual risk, because it could be, for example, that there are third parties involved in the creation of the AI system, and they might have a different concept of what the risk is from what yours is. Issues could be coming from their software, which you're using in your system, their hardware, their data. It could be that you have different organizations developing an AI system and deploying it, and the people deploying it have a different concept of risk from the people who are developing it. And then, of course, you have the users who will have their own risk tolerance, their own concept of what is a risk and what is not. The availability of reliable metrics. How do you measure these risks? The difference between risks at different stages of the AI lifecycle. So you have the people who are gathering data will have some concept of risk, the people developing the model, the people using the model. The risk that the data you're using in the lab isn't representing the risks you would have with data in a real world setting, because of course data in the real world setting has different things impacting on it. Inscrutability. Some models have limited explainability or interpretability. And then, of course, there's always the human. AI systems carry out tasks differently from humans, but in the end, it is humans interpreting the results. And so you end up having risks associated with the humans that are in the picture. So we need to prioritize the risk, and each organization will have a different tolerance for risk. It is, of course, not practical to try to eliminate all risk, but if an AI system presents unacceptable risk levels, then deployment and development should cease until the risk is managed. Then we have organizational integration. So AI risk management should be integrated with the broader enterprise risk management. Many of the risks of AI overlap with general software development risks like privacy, cybersecurity, environmental impact, confidentiality, availability. So all of those need to be part of your considerations. So NIST has a document, the AI 600-1 RMF, and this is a particular profile for generative AI. So remember, we have the core, which is general for all areas of AI, and then the profiles, which are specific to particular areas. So let's look at this one just as an example of the things that they would introduce. So this profile helps organizations to identify risks that are unique to generative AI. So things like chemical, biological, radiological, or nuclear risks. Confabulation. This is when an AI system generates false or misleading information. Dangerous or violent recommendations from generative AI. Data privacy. Data can easily leak in the results that you get from generative AI. There are full profiles for many areas that are available at nist.gov. Now, in the profile for generative AI, they talk about dimensions and actors. These are essentially socio-technical dimensions of an AI system, and there are 5 of them. Each dimension has actors who are the audience for the AI RMF. For example, we have people and the planet. We have data and input. We have the AI model itself. And then we have the tasks it is given and the output produced. Then we have the application context. And in all of these, you have actors and you have the operations that they're going to do. So in all these dimensions, the actors will have to perform various operations. In particular, they need to test, to evaluate, to verify, and validate the processes that are going on in their particular part of the system. So, for example, the people who are doing the data and data input, the people who access the data in the first place, they need to make sure that the data that they're putting into the system has been validated both internally and externally before it even gets to them. Test to see that it is valid, that it is unbiased, that it is relevant. And then, as you can see in all the other dimensions, the framework mandates that the actors are going to perform other testing, evaluation, verification, and validation, or if you like, TEVV tasks to ensure proper data governance. So this is from NIST. We also have other bodies like ISO and IEC. ISO, this is the International Organization for Standardization, and it's a federation of more than 160 national standards bodies, and it develops standards for products, services, and systems. We also have IEC, the International Electrotechnical Commission. It publishes international standards for electrical, electronic, and related technologies. In particular, there is a document, the ISO/IEC 27050-2, developed by the two bodies, and it's a standard that is published jointly by them, and it addresses risk issues related to electronically stored information during electronic discovery. This is as you process it, as you identify the data you're going to use, you save it, you preserve it, the collection of that data, reviewing the results you're getting from that data, putting your model into production. So mitigation of risks unique to AI is best managed through frameworks, including the ones developed by NIST and ISO/IEC. Now that we've introduced you to frameworks and best practices in AI governance, please join us for more information on AI from Learning Tree International.